So this video is going to be to help you find the graph for your amazing race problem. So when we make this graph it's going to be a time versus distance graph. So on the x-axis I have the time that it's taking me to run, and on the y-axis I have the distance from the starting line in miles. And notice the time is in hours, because when you're trying to graph something, if you try to do it in hours and minutes, it's going to get a little bit weirder. So just keeping all of the time in hours is going to make your graph a lot simpler. So here I made up this data for Mr. Merced. We'll say he ran the half marathon as well, although I'm not sure he can make it 10 miles. I'm just kidding, don't tell him I said that. But let's say he ran this half marathon too. So he did 3 miles at 5 miles an hour, 5 miles at 9 miles an hour, and then he ran the rest of the race at 7 miles an hour. So this would be his total time for the race. This is something you should be familiar with calculating. There's the 3 miles per hour, or the 3 miles in 5 miles per hour, the 5 miles at 9 miles per hour, and then the 5.1 miles at 7 miles per hour. And altogether that comes out to 1.88 hours. In order to make this graph, we need to remember that this is going to be 3 different line segments because he's going at 3 different speeds. And on a graph like this, your speed is really your slope. So we're going to have one line segment for this part where he's going 3 miles at 5 miles per hour. It's going to work. Right, so that's going to be one line segment. The next 5 miles at 9 miles per hour is going to be a different line segment because it's going to have a different slope. And then the last part is going to be a third line segment. So, in order to make that first line segment, what I need to remember is that he went 3 miles going 5 miles per hour. So how long did he take to go those 3 miles? Because I know how far he went. This 3 miles is going to be, that's going to be the y for my first point, right? So I need to know what x is for that point. So in order to find that, it's going to be this 3/5, because he went, so time for the first part is going to be 3, because he went 3 miles at 5 miles per hour, and that's going to be, well, 3/5 or 0.6, if you will. So my first point here is going to be, I'm going to go out to 0.6 on the x-axis because the x-axis is time. So it's just a little bit, there's 0.75. So maybe about here is 0.6. And then up to, he went 3 miles going that speed. So I go up to y equals 3. So this point is 0.63, right? And then I can just draw, since I have 2 points, I can make a line to connect them. And there's my first segment, right? In order to get the second segment, well, I need to figure out how long did he spend going 5 miles an hour. So he starts at 0.6, and then he's going to take an additional, so time 2 is going to be 5 over 9. Which is 0.5 repeating, or 0.556, right? So he's going to go 5 more miles, and he's going to spend 5/9 of an hour, or 0.556 hours, going that speed. So I'm not going to go to 0.55, because I mean that would be going backwards, but I'm going to take, so that second leg is going to be, I'm going to add these 2 times together because that's his total. So 0.6 plus 0.556 is going to equal 1.16. All right. So my second point is going to be, he went 5 more miles, so I'm going to go all the way out to 8. So he's now at 1.16 hours, so 1.16 would be about here-ish. And then I'm going to go up to 8 miles because that's the total amount of distance he's covered at this point. So this is 1.16, comma 8. And now that I know where he started and I know where he ended. And you can see based on the slope, he's obviously going faster, that second part, than he was the first part. And for the last part, I'm going to do the same thing. I start with, he's already gone 1.116 hours. He's already taken 1.16 hours. So my third time is going to be the time it takes him to finish the race. So third time is going to be 5.1 over 7, which is 0.73. Oh, you know what? In fact, since I know how long it took him to finish the race, so 1.16 plus 0.73 plus 0.556 is going to equal 1.88, which is how long it took him to finish the race, because that's the last leg of the race that he has. There's the 1.88 that we already found. So the last point is going to be 13.1, because that's 13.1 on the y-axis, because that's how far from the start line is, and 1.88 here. About there. So this point is 1. That point is 1.88, comma 13.1. And then I can draw the line to connect those. So you can see he definitely slowed down a little bit because he was only going 7 miles an hour. So all three of these slopes are different because all three of these speeds are different. Now, how would you find the equation of these three line segments? Well, you know the slope of each of those line segments because the slope of each of those segments is in fact the speed that he is going. Slope, 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 right? And for each of those line segments, you know a point that it passes through. The line segments 2 and 3 both pass through this point. The first and second segments pass through this point. Obviously, the first one starts at the origin, so that's an easy one. So I'm not going to show you how to find these because I know that you already know how to find them. You might review the how to write linear equations notes if you need a refresher. You're essentially going to be, you know the slope and you know a point, so you can solve that equation for the y-intercept. All right, I hope this was helpful.